Hello and welcome to this tutorial on how to set up Kubernetes on your local system. In this lab, we are going to install a basic Kubernetes cluster using the Minikube utility. Now, in this lab, we are going to perform the following steps. First, we will install and set up kubectl. Second, we will install the hypervisor, which is going to be Oracle VM VirtualBox. Then we'll install the Minikube, and lastly we'll create some deployments using the cluster. So let's start the setup. Let's go to kubernetes.io page, and within this website click on the documentation section. Here navigate to tasks and then install tools, and here you'll see the options for installing and setting up the kubectl on different operating system. For now I'm using Windows, so I'll select Windows. You can select the option based on what operating system you're using. Select the option, and now here you have all the steps to set up the kubectl on your operating system. Now, kubectl is the command line tool that allows you to interact with Kubernetes. It allows you to run commands against Kubernetes cluster. You can use kubectl to deploy applications. So let's start with the first step. Now download the latest patch release of kubectl, or you can just copy the command and run it in your PowerShell in Windows. So just copy and paste the command for downloading the kubectl binary. The binary has now been downloaded. Now you just need to follow these steps to set up the kubectl. The second step is optional for now. In the third step, you need to append the kubectl binary folder to your path environment variable. After that, you need to ensure the version of kubectl. So let's run the kubectl version command, and you can see that it has installed 1.27 version. Now after installing the kubectl, now we need to set up the Minikube. To do that, go to the end of this page, and here click on install Minikube link. Now the first thing we need to check, regardless of what operating system you're using, is to make sure that virtualization is enabled for your system. If not, then you can enable it from your system BIOS settings. Now let's install the Minikube, but first we need to install the hypervisor, as we have two prerequisites to install before setting up the Minikube. First one is to set up the kubectl, which is already done, and the second one is to install the hypervisor. For that, go to the virtualbox.org, and here you can select and download the VirtualBox based on your system specifications. I've already downloaded and installed it in my system, and this is what the VirtualBox interface looks like. Here for now we don't have any virtual machine listed, but when you set a Minikube, it will automatically create a virtual machine as required. So let's continue with the Minikube installation. To do that, you need to follow these steps. As we are using PowerShell to set it up, so let's copy the first command and paste it in our PowerShell terminal. So this will download the Minikube binary and assign an execute bit so that we can run it as command. And once that has been done, we have to add the Minikube binary to our path. So copy and paste the second command, and now it's done. So now let's start the Minikube by using Minikube start command, and now you'll notice that it is creating a virtual machine. Let's go to our VirtualBox, and here we'll see that the virtual machine by the name of Minikube has been created and currently is in running state. Let's wait for this setup to complete. After that, we'll check the status by using Minikube status command. And here we can see that Minikube is in running state. After that, you can access your new cluster by using command kubectl get po-a. Now the last step is deployment. So to do that, follow these steps. First, copy and paste these commands to create a sample deployment and expose it on port 8080. Then we'll use the command kubectl get service hello minikube to retrieve the information about Kubernetes service name hello minikube. And then we will use the minikube service hello minikube to let minikube launch a web browser in order to access this service. Now you can see the details of the application like this. And this is the proof that your setup is working. And now to clean up your system, which is deleting the service and deleting the deployment, you can use kubectl delete service hello minikube to delete services and kubectl delete deployment to delete the deployments. That is it for this video on how to set up Kubernetes in your local machine. Hello and welcome to this tutorial on how to deploy a pod in a minikube cluster in Kubernetes. Now, a pod is the most basic and smallest unit in the Kubernetes. It's like a single instance of a process running on your cluster. So we will use the kubectl command line utility to interact with the Kubernetes cluster. Now run the command kubectl run nginx, which is the name of the pod -- image equals to nginx. Now here is where we specify the Docker image to be used, while the pod could be anything. The image name has to be the name of an image available at Docker Hub or any other container registry. Now when we run this command, we see a pod by the name nginx has been created. And you can check the status by using kubectl getPods command. Here you can see the status is running. Also, we can get more information about the pod by running the kubectl describe pod nginx command. And you'll see that it provides a lot more information about the pod. For example, the name of the pod. Also, it shows any labels that has been assigned to this pod, and it shows the start time, the nodes that it is assigned to along with the IP address of the node, and also it shows the IP address of the pod itself. Moving on, we can see that it also displays information related to the container, and we know that there is a single container which uses the image nginx. If there were multiple containers, they will be listed here as well. And if you scroll all the way to the bottom, you'll see additional information called events. And here you'll see the list of events that occur since the creation of the pod. It went through multiple stages before it started. We can see that the pod was assigned to the minikube node, and then it enters the pulling phase where the nginx image was pulled down from the Docker Hub successfully. And then the container was created and then started. Now there is another command as well that we can use to check the status of the pod, and that is kubectl getPods -o white. And this provides additional information such as the node where the pod is running and the IP address of the pod as well. That is it for this video on how to deploy a pod in a minikube cluster in Kubernetes. Hello and welcome to this tutorial on how to create a pod using YAML-based configuration file. Now in this lab, we're going to create a pod again, but this time instead of making use of kubectl run command, we are going to create using a YAML definition file. So our goal is to create a YAML file with the pod specifications in it. Now there are many ways to do it. You can use any text editor if you're on Windows like Notepad or Notepad++, or if you're on Linux, you can use their editors like VI or Vim. So right now I'm using Notepad for the YAML file, and If you're using Notepad, you have to save it with the .yaml extension. I saved the file with the name pod.yaml. Now let's start with the 4 root elements, which are API version, kind, metadata, and specs. So we know that the value of API version for pod is v1. The kind is pod. And metadata is a dictionary, so it can have values where we can define the name of the pod, which is in this case is Nginx. And we can have additional labels that we can specify under it. So now labels is also a dictionary, so it can have many labels as you want. So we can specify a label which is a key value pair such as app, Nginx, and we can add more labels like tier. Next, we have to define the spec. It is also a dictionary and it has an object called containers. So now there could be multiple containers in a pod and each can have a different name. For now, we're going to use the same name as the container image. And the second object we are going to add here is image name, which is the Docker Hub image name of the container that we are going to create. And if you're using other registries than Docker Hub, then make sure to specify the full path to that image repository. Now, one thing we have to check is that we get the indentation right and the spacing is correct for the children and parent properties. Now, let's save the file, and in the PowerShell, we'll first make sure that the file was created using cat command. So now we can see it is created, and the other thing we have to make sure the format and indentation is correct. We can make use of kubectl apply-f command to create a pod. Now we can see that the pod has been created. So let's check the status quickly by using kubectl get pods command. And you can see that it is in running state. That is it for this video on how to create a pod using YAML in Kubernetes. Hello everyone, welcome to this tutorial on creating replica sets based on the pod definition file that we created earlier. So in the last video, we created a pod using YAML. So now let's create a new directory for the replica set, and I'm using Visual Studio Code for creating the YAML files. Inside this directory, let's create a new file called replicaset.yaml. So again, let's start with the API version, and the version for the replica set is apps/v1. And kind will be replica set. Next, we have to add metadata. So the name of the replica set would be my app-replica set. And we'll assign a label for our replica set as well. So the key would be app and the value will be my app. The last property is spec. And for replica set, it needs a selector, and also the Visual Studio already created a selector field for us. So we just have to fill it in. And here I'm selecting match labels option. And here we are going to use the same label that we used for the pod. So to use the same label that we used before while creating pods, open the Nginx file and copy the labels. Now the next property is replicas. So for now, let's use 3 replicas. And the next mandatory value that we need to add here is the template. And so for the template, we can make use of the pod definition file that we created earlier and copy the template. So just copy the whole section from metadata and paste it under the template section. Now, as soon as we paste it here, it will give indentation errors. To fix that, just select this section and press tab 2 times. And it'll fix the indentation errors. Now one thing to note here is that the labels used for the pods and the labels used under the selector have to be the same. The labels used at the top of the replica set doesn't really matter. The selector and the pod labels matters here only. So they have to be the same. So now I'm changing the labels to my app here. Now we are done with the file. Let's save the file and go to the PowerShell to check the file. So here, let's quickly go to the directory where we save the replica set file, and let's check the file. To view the content of the file, let's run a cat command. So now we are going to create this replica set using the kubectl create command with -f option. And now you see that the replica set is created. Now let's check the status using kubectl get replica set command, and we notice that there is one replica set created already. The desired number of replicas is 3, and the current and ready number of replicas is 3 as well. Now we can further inspect the status by running the kubectl get pods command, and we notice that here we have 3 pods for the replica set we've created, and all of them have unique name. But the name of the pod begins with the name of the replica set, which is my app-replica set. So that's how you can check if it is a standalone pod or the part of the replica set. So now a replica set ensures that a sufficient number of replicas or pods are available at all time. Now let's see what happens if we delete one of these pods. So let's copy one of the pod names, and we are going to use kubectl delete pod command to delete one of the pods. So whenever you delete a pod, it will take a few seconds to delete the pod. Now let's check the status again. Here now you'll notice that the replica set still has 3 pods running, and you'll notice that one pod is newly created pod, and the name of the pod is also changed. It is because the older pod is got deleted, but it creates the new pod in place of that deleted pod, ensuring that a sufficient number of pods are always available on the cluster. Now if you run the kubectl describe replica set command for the new replica set, we can see more information about the replica set, just like what we saw with the kubectl describe pod command. Here we can see the name of replica set, the selectors and labels, etc. And if you scroll all the way down, you'll see initially we have 3 replicas, but then we deleted one of the replica and it adds one more replica in place of that. Now let's see what happens if we create a new pod by making use of the same label of replica set, which is the app set to my app outside of the replica set. To do that, let's open the nginx.yaml file by using cat command, and here you will see we change the labels to the same label as the pod definition template that used in the replica set. So now let's create the pod directly, and we'll see what happens when we create a new pod outside of the replica set but has the same labels. So first let's check how many pods are running by using getPods command, and we'll see that only 3 pods are running for the replica set. Now run the kubectl create command with the -f and specify the file name, and you'll see that the pod has been created. But if I run the kubectl getPods command, now we can see that the status of this pod is in a terminating state. It is because the replica set is terminating the new pod that we just created. It is not allowing more pods with the same labels than the number of replicas configured on the replica set, which is 3 at this time. Now let's see how to update the replica set. So if we want to change the number of replicas to 4 instead of 3, for this we must edit the replica set definition file and update its replicas count to 4. For this we use kubectl edit replica set command, and will provide the name of the replica set. Now when we run this command, we see that it opens the running configuration of the replica set in a text editor. Now this is not the actual file that we created at the beginning. This is the temporary file that is created by Kubernetes in memory to allow us to edit the configuration of an existing object. Now scroll all the way down to the spec section and change the replicas from 3 to 4, and then save and exit from the file. And now it will add a new pod in addition to the 3 that you already had to match the new number of the replicas. So when you run the kubectl get pods command, you'll see that there is new pod that is created 26 seconds ago. Now there is another way to scale the number of pods without editing the definition file, and that is using the kubectl scale replica set command. So we'll provide the name of the replica set and we'll specify the number of replicas. So now if we run this command, it will scale down the replicas to 2. And to check this, run the get pods command again, and you'll see we have now only 2 replicas available. Hello and welcome to this tutorial on how to create deployment in Kubernetes. Let's start with our lab. First, let's create a new folder with the name deployments in our project directory. And within this folder, let's create a new file named deployment.yaml. And we are going to make use of definition file that we created earlier for the replica set because it's quite similar to the deployment. So let's open the replica set file as well. Let's start with the API version, which is gonna be apps/v1, and kind would be deployment, and also metadata have names and labels as well. So I'm going to use the name my app-deployment, and we'll add some labels as well. So tier would be front end, and another one would be app set to nginx. Now the spec section is very much similar to the replica set. So just copy the entire spec section from replica set and paste it over here. And now we're done with the YAML file. So let's save it and let's go back to our terminal. Here, let's quickly go to the deployment directory. And here I'm going to create this deployment using kubectl create command along with the -f. Now the deployment has created. So let's run the kubectl get deployments command, and you can see that we have one deployment created and has 3 out of 3 ready pods and 3 available as well. And if you want to check the pod, we can run the kubectl get pods command, and we can see that we have 3 pods which are in a running state. Now let's run the kubectl describe deployment command, and here we can see a lot of information about our deployment, like the name, labels, selector, pod template, etc. Now let's run the kubectl get all command, which shows all the objects which is created in the cluster. And so you can see that we have one deployment that we created, and there is a replica set which is created for that deployment. And we have 3 pods which have been created using that replica set. That is it for this video on create a deployment in Kubernetes. Hello and welcome to this tutorial on services in Kubernetes. Now in the previous lab, we've created few pods by creating a deployment. So first, let's check the status of that by using kubectl get deployment command. So we have a deployment called my app-deployment, and it has 3 replicas, which is essentially 3 pods running in the Kubernetes cluster. So let's check it by using get pods command. Now we have an application which is created to run on this cluster, but for the end user to access it on their web browser, we have to create a service. To do this, let's go back to our editor. Here we have created new directory called service, and in that directory, let's create a file name service definition.yaml. The first thing, as always, would be API version, and for service it should be set to v1. kind would be service, and we're going to add metadata with the name of service, which would be my app-service. And after that, we're going to add the spec section, and the first property would be type, and it is set to node port. Now our goal is to be able to access our application on a port on the node, which is the Minikube node. Now we will add the port, and the default port in which Nginx listen is 80. And we're also going to add the target port, which is also will be port 80. So this is basically port on the service itself. And now we are going to add the node port, which we can set to a value between 30,000 and 32,767. Next, we are going to add selector, which helps bind our service to the port with the same label. So quickly, let's check the deployment YAML file. And you'll notice that label for the port is app set to my app. So let's add the same in service file as well. So now our service definition file is completed. So let's save it and let's go back to our terminal, and let's quickly navigate to the service directory and check our new created file. Now I'm going to create the service using kubectl create-f command and specify the YAML file. Run this command and you'll see the service has been created. We can now run the kubectl get service command, and here you can see the new service with name my app-service, and type of the service is node port. And here is the cluster IP, which is also created for that service. And here is the port on the worker node that we can use to access our application. So if you know the IP of the worker node, you can simply go to the browser and just type in the IP of the worker node followed by the port number, and you should be able to access this application. Now since we are running this on Minikube, so we can also run the Minikube service command followed by the name of the service, my app-service, and type --URL, and it should print the URL where the service is available. So let's try to access it on our browser. Copy and paste the URL, and we see the default Nginx web page. And that confirms that the Nginx application is up and running, and we're able to access it on a web browser. That is it for this video on services in Kubernetes. Hello and welcome to this tutorial on deploying PHP guestbook application with Redis in Kubernetes. This tutorial shows you how to build and deploy a simple multi-tier web application using Kubernetes. Now you can also find this example on Kubernetes official website. Just go to the following link and you'll find this example. Now what we're performing in this lab, first we will set up the Redis leader by creating Redis deployment and service. Then we set up the Redis follower and guestbook frontend. After that we'll expose the guestbook frontend, and in the last we'll clean up all the deployments and services. So let's start with the first step, which is creating deployment for Redis. Now we don't need to actually create this file in our local system. Instead, we just simply run the below command kubectl apply-f and give the address of this YAML file, and it will create the deployment. And we can check it by running kubectl get pods command, and you'll see its status as running. After creating deployment, you need to create service for this deployment to connect to the application frontend to its backend. we'll use the same command kubectl apply-f and give the address of this service YAML file, and it will create the service. And just like deployment, we can check the status of the service by running kubectl get service command. Next, we need to set up the Redis followers to make our application highly available and meet the traffic demands. And just like Redis leader deployment, we will apply the Redis follower deployment as well. By using the same command kubectl apply-f and giving the address of the deployment, we can create a Redis follower deployment. Let's check the status, and you will see that it is now creating 2 more replicas for Redis. And if you check again after some time, you'll see their status as running. Now we need to create a service for this as well by using the same apply command. So let's just copy the command and paste it here and press enter, and you'll see the service being created. And to verify the service actually running or not, you can run the kubectl get service command and you should see your newly created service here. Now that we have the Redis storage for our guestbook up and running, next thing we need to do is to start the guestbook web server, and like the Redis followers, the front end is deployed using Kubernetes deployment. So first we will create the deployment for guestbook front end the same way using kubectl apply-f command. Once it is created, then we will check the list of pods to verify that the 3 front-end replicas are running, because we set the values of replicas in our file 3. Now to do that, copy this command and paste it in your terminal, and you'll see 3 replicas are in creating status. Wait for some time and run it again to verify their running status. Now we need to create service for this as well, so use the same apply command and give the address of the service YAML file, and we're good to go. Now we have all the services and pods are running, so let's view the front-end service using kubectl port-forward command. You can copy and paste this command as it is, and the response should be like this. Once you got the response, you go to the browser and type in http localhost:8080 and press enter, and you'll see your guestbook application. Once it's running, that means all the things are working fine. Now the other thing you can do is to scale up and down the number of front-end pods. Type in the following command kubectl scale deployment frontend and set the replicas equals to 5. And now when you check the status, you will see 3 more replicas are added because we set the value to 5 and we already have 2 replicas running. Now if you want to scale it down, you can just change the values of replicas here and it will scale it down to whatever the value you gave. In this case, it is 2. Now we're done with the deploying application, and if you're not using it any further, you have to clean it up, otherwise it will keep using the resources. So run the kubectl delete command followed by the name deployment -l and app equals to Redis. Do the same with service as well to delete the service and deployment for Redis, and delete the deployment and service for front-end as well using the same command. Double check it with kubectl get pods command and you'll see no resources found message, which means all the deployments and services are deleted. That is it for this video on deploying application from your local system in Kubernetes. I hope you like this tutorial. Thanks for watching and have a great day. Bye.